All right, this is Coach Williams, and we're going to continue in Chapter 5 with Section 3. We've been solving systems of linear equations. The first section, 5.1, was solving by graphing. 5.2 was solving by substitution. And 5.3 is going to be solving by elimination. We're going to need to get one of our vocabulary terms out of the way here, coefficient. We've talked about coefficient. We have a pretty good idea of what it is. But let's give it a formal definition here. It's going to be a numerical value placed before a variable. A numerical value placed before a variable and multiplying the variable by the value. As an example, we may have 4x. Well, it just simply means we're multiplying 4 times x. So 4 is the coefficient. It is a numerical value placed before x, the variable x, and it multiplies the variable x, whatever x ends up being, by 4, by the value of 4. So that is what a coefficient's definition is that we're going to give it for today. And that's going to be important to us as we move along because we're going to have to look at coefficients when we're doing elimination, the process of elimination with equations. So here's the steps, and I'm going to go ahead and give you the steps. Again, this may sound like gibberish at first, but as we move along, it's going to make more and more sense. So the first step, multiply, if necessary, one or both equations by a constant so at least one pair of like terms has the same or opposite coefficients. Now that's a lot to take in. But we're going to look at the coefficients in the two equations. We're going to look at both the x terms and both the y terms. We're going to try to get the coefficients in front of the x's the same. If that's not as easy as doing the y's, then we'll look at the y's and try to get the coefficient in front of the y's the same. So that way, whenever we add or subtract the two equations from each other, which is what we're going to do in a minute, it will make one of those variables go away, thus eliminating it. And so we can will only be trying to solve for the other variable that's left. All right, so the second step is to do just that, add or subtract the equations to eliminate one of the variables. Let's write this down. If the signs are the same, we subtract. We subtract. If the signs are opposite, we add. So there we go. We'll fix that. If the signs are the same, we subtract. If the signs are opposite, we add. If the signs are the same, if I've got 4x and 4x, and I'm trying to get rid of one of those 4x's, I need to subtract one of the 4x's from the other one. So if they're both positive, then I need to subtract. Or if they're both negative, I'll need to subtract. If they're negative 4x and a positive 4x, then I'll need to just add those together and they'll go away. And we see that every time we move something from one side of the equation to the other. If it's a positive, how do we get rid of it? Well, we change the sign to a negative, or we subtract it and it gets rid of it. If it's negative, then we add whatever it is and it makes it go away. So we need our signs to be different in order to combine them by adding and make them go away. So if the signs are the same, we subtract. If the signs are opposite, we add. We solve the resulting equation, and then we substitute the value that we find from step 3 back into one of the original equations and solve for the other variable. Again, that's kind of gibberish maybe until we get moving along here, but it'll make sense as we do the examples. Let's look at the extra practice, number 1. Okay. If you'll look here, can you see in the problem in the two equations that there is a coefficient in front of one of the variables that's the same and its opposite signs? Do you see that in one of them? Is it x or y that has the same coefficient? Opposite signs. It's x. X has a coefficient of 1. There's a 3 in front of the y here and a 2 in front of the y here. But on this equation, this top equation, I've got a positive 1. Here I have a negative 1. And if I were to add positive 1 and negative 1 together, then that would go away, wouldn't it? And that's what we're going to do. The signs are opposite. Okay, so it's opposite sign. So we're going to add. It's opposite sign, so we're going to add. So we're going to add the entire equations to each other. Now, we're also obviously going to make sure that we've got our terms in the same order so that we're adding or subtracting like terms. We're going to add our x terms together right now. What is x plus a negative x? 0. What is 3y plus 2y? 5y. What's 17 plus 8? 25. So now you notice, because we added these two together, the x terms went away. Thus, we eliminated one of the variables. And now we can just solve for the y value. All right, so we're going to solve for the y value by dividing by 5. Dividing by 5, y is going to equal a positive 5. Now we can take that and we can plug it in to either equation and get our x value from substituting the y value in. All right, I'm going to choose the top equation because x is positive, and it just saves me from having to deal with sign problems whenever I'm dividing later. So I'm going to choose the top equation. X plus 3 times, what's the y value? 5 equals 17. Okay, so x plus 15 is going to equal 17. So I will subtract 15 from both sides, or I'll just move this positive 15 over here, which means I change the sign. Anytime it crosses the equal sign, it changes its sign. So I'm subtract 15, x is going to equal a positive 2. So I have both my x and y values. The solution to this system of equations is 2, 5. That's the ordered pair, or the solution to this system of linear equations. And we can check that very easily. We use the top equation to get this value. So let's plug it into the bottom equation, just make sure it checks out. Negative x, or negative 2, plus 2 times positive 5. Well, negative 2 plus 10, 2 times 5. Negative 2 plus 10 is an 8, and 8 does equal 8. So it checks out on that bottom equation. And so that's definitely the answer here. 2, 5 is the ordered pair solution to our system of equations. All right, let's look at number 2. Number 2, again, we have similar or the same coefficient but opposite signs. Which variable is it this time? It's the y variable. If you notice, in front of the y variable, we've got a negative 1, and the other y variable, we have a positive 1. So using this right here, we can eliminate those if we add them together. Right? We have opposite signs again. And so we're going to add. So we're just going to take both equations and add this column together. Add the y column together. Add the integer column together. 2 plus 5 is going to be 7x. Negative y plus y is going to be 0. 5 plus 16 is going to be 21. So basically, the 0 just goes away, and we're left with 7x equals 21. Now, if I want to solve for x, I divide by 7, and x is going to equal 3. And then again, I can take this and plug this in to either equation and find out my y value. And I am also, again, I'm going to take the bottom equation because the y is positive and just makes it easier not having to divide out the negative in the end. So I'm going to take the bottom equation and I'm going to solve for y. 5 times the x value, which we found to be 3, plus y equals 16. 5 times 3 is 15, plus y equals 16. We're going to take this positive 15, move it across. Oops, sorry, I wrote 15. It's supposed to be 16. We're going to take this positive 15, move it across to the other side. We know it just changes sign. Or if you want to subtract it from both sides, it's the same thing. Minus 15. So 16 minus 15, y is going to equal 1. So we have 3 and 1 as the solution to this system of equations on number 2. And we can check that by plugging those in. For sake of time, we're going to try to get some more examples done. All right, number 3. Number 3, again, we have some variables with the same coefficients, just opposite signs. And which one is it on number 3? Does anybody start to recognize this off the bat here? It's going to be which variable, x or y? X. X has a 2 in front here and a negative 2 there. It is, again, opposite signs. And I'm just writing this just for repetition so you keep seeing it here. And hopefully this will start to sink in. This is going to be addition, because addition will make those two go away. So that'll be a 0. Adding those together. Adding my y terms together. I'm going to get a 2y, positive 2y, 3y minus y basically. And then I'm going to have 10 plus a negative 2. 10 plus a negative 2 is going to be 8. So I'll divide by 2, and y is going to equal a positive 4. Okay? I'm going to plug that in. Again, I'm going to use the positive one. Positive x equation or positive x term so that I can save from dividing by negatives. It doesn't really matter too much, but just maybe it helps a little bit, hopefully. All right, so I'm going to have 2x plus 3 times 4. Okay, I'm going to plug that 4 right there where the y is supposed to be. And then that's going to equal 10. Well, 2x plus 12 equals 10. 10. So then I'm going to move this 12 to the other side. So a positive 12 will become a negative 12 when I subtract it from both sides. So then 2x is going to equal a negative 2. And I divide by 2, x is going to equal negative 1. So the solution to this system of linear equations is going to be a negative 1, 4. Negative 1, 4. All right, let's look at number 5. Number 4 is going to be very similar to what we've just worked, but on number 5, they're starting to make us do a little bit of work to get these into the right order. And that's okay. That's not a problem. We can move things around fairly easily. We should be pretty efficient at that at this point. But we need this in the standard form. If you notice, all these equations have been in standard form. AX plus BY equals C. Well, this one's not in that order, so we're going to have to move some things around. We're going to have to take the 18 and move it to the other side, which just means it's going to be a positive 18. We're going to add 18 to both sides. We need to take this y and move it to the other side, which just means it's going to be a negative y. Okay? So our resulting equation is going to be 3x minus y equals 18. Now, just for visualization, I'm going to move this equation right here below it so that they're stacked on top of each other, and we've got them right beside each other so we can look at them and see what needs to be done so we can eliminate something. 2x plus y equals 12. Okay, now we're in the same position as we were in our previous problems. We've got the y variable with the same coefficient, just opposite signs. So this is going to be easy. We've got opposite signs, so we're going to add. And when we add this together, we're going to end up with 5x plus 0 equals 30. And then we know that we'll just divide by 5. The 0 just goes away. We'll divide by 5 here, and x is going to equal positive 6. Take that positive 6, and then we can just plug it into either one of these two equations. I'm going to pick the one with the positive y here because that's what I'm solving for. So I'm going to plug it into this bottom equation. When I do that, I'm going to have 2 times 6 plus y equals 12. Well, 2 times 6 is 12 plus y equals 12. And we know that anytime we have the same number on both sides of the equal sign, same number, they just cancel, because when I minus 12 from this side, it minuses 12 from that side. So that goes away, becomes a 0, y equals 0. And that is going to be my solution to this system of equations, 6, 0. Six comma 0 will be the answer to number 5. All right, number 6 is going to be worked the same way. I won't work the entire thing, but you'll just have to move some things around. This has the ax plus by equals c, so we'll just have to move this term to the front over here, which will make it negative. And then by doing that, we're going to have this in the right form or the right format to line these up. And then also you'll notice I've got a positive 4x here, a negative 4x here. That goes away. I can line these up. I can eliminate the x term first by just adding them together. I can solve for y, plug it back in, and solve for x. So this will be very simple to work out, just like the ones we've done before. And again, for sake of time, I'm going to move on to another problem with a few other things to do that we need to make sure we understand and see some examples of. Number 7. Number 7's much like the one we just talked about. We're going to take and move some stuff around to get it where it needs to go. We'll go ahead and work number 7 because number 7 gives us a little bit of trouble. It ends up being some fractions, and I just want to make sure you understand we can do fractions. Everyone say, I can do fractions. Yes, that wasn't very loud, but not very confident. But I'm going to hopefully help you be confident in doing fractions here. We're going to move this 4y to that side of the equal sign. We're going to move this negative 4x to that side or right there of the equal sign. So our two new equations, when I subtract 4y from both sides, the top equation will be negative 4x minus 4y equals negative 2. This one will be a positive 4x because that's negative, so it would be a positive 4x minus 4y equals a positive 1. All right, now you notice here rather quickly that the 4's are the same coefficient, just opposite signs, so we can take this right here and just add them together. When we add those together, we're going to eliminate our x variable terms, because that's going to be a 0. This will be negative 8y, and this will end up being a negative 1. And so then when we divide both sides by negative 8, divide by negative 8, there's the dreaded fraction. But don't worry, it's okay. This is a dragon we can conquer. That's going to go away. Y is going to equal positive 1 over 8. Now, if it's easier, as we mentioned in previous videos and classes, if it's easier to put that in decimal form, then do it in decimal form and do it on the calculator. That's not a problem. But let's do it, leave it in fraction form so that we can show you that it is doable and it's not too difficult. We're going to take that 1/8 and we're going to plug it back into, I'm going to use the bottom equation here. Bottom equation because, again, it keeps my x term positive, and that's what we're solving for. So I'm going to have 4x minus 4 times 1 over 8. And 1 over 8 times 4 is just going to be simply 4 over 8, or 1/2. We'll change that in a minute. That's still going to equal a positive 1. Alright, so again, like we mentioned, 4 times 1 is 4. Over 8 is going to be 1/2. So this whole thing becomes a 4x minus 1/2. Still equal to 1. I'm going to have to move over a little bit and work this problem to the side. In fact, I tell you what, I'm going to move it over here to the left side. So I'm going to move this over here. This is going to be moved right over here. And we're going to say we're going to take the 1/2 and we're going to add it to both sides, right? We're going to move this over here, so it means we're going to add 1/2 to 1. Well, it's simply 1 and 1/2, or if you change this to a improper fraction here, it's going to be a 3/2. So 4x is going to equal 1 and 1/2, or 3/2. Then we're going to have to divide by 4, which just means we're multiplying by 1 over 4. Multiplying by 1 over 4. You divide by 4, you're multiplying by 1 over 4. That makes those 4's go away. X is going to equal 3 over 8, or 3/8. Alright, and so we do have fractions for both of our terms. That is the solution. It is 3/8 and 1/8. So I'm going to mark it right here. 3/8, 1/8. And we use this bottom equation to solve it, to solve for x. So we know that that is the value that we're going to get. Let's plug it into the top one just to verify that it is correct. And now again, this gets a little bit tricky, but let's verify it with the top equation. Okay, we're going to have, and I'll do it off to the side here, we're going to have this top equation using our two variable values that we found for the solution. We're going to have -4 times 3 over 8 minus 4 times 1 over 8. And that's supposed to equal -2. So we're going to take -4 times 3. It's going to be a -12 over 8. Minus 4 times 8, or 4 times 1 over 8, so it's going to be 4 over 8. Still supposed to equal -2. Well, that should be 8. -12 and -4 make a -16 over 8. And when we divide -16 over 8, it does equal a -2. So it checks out. So that is correct. It is it's 3 over 8, comma 1 over 8 for the solution to this system of equations. Again, if you did this with a calculator, it's going to be a lot easier to check it because you can put it in decimal form, or you can just have the calculator do the calculations for you. All right, let's look at number 8. Number 8, again, this one is in standard form, but if you'll notice, we don't have the same coefficient for either variable. So now we're going to have to start multiplying a number times the equation. And you may remember this from one of our previous chapters here when we talked about equivalent equations. We can multiply or divide by any number as long as we do it to the whole equation, and it is the same equation. It's equivalent to it, but it should be able to help us out when we're trying to do elimination. So if I'm going to work with the x's, let's work with x's for a minute. If I want to work with x's and I want the coefficient in front of x on the first equation to be the same as the bottom one and maybe opposite sign, what would I multiply the top equation by so it would help me eliminate the x term? Does anybody know what that would be? I've got a +2 here, and I want the coefficient in front of x here to be a -2. Well, I'm just going to have to multiply the whole thing by -2. So if I take -2, multiply the entire equation by -2, I'm just going to rewrite this on this line below it here so that I can keep these together. This is going to be -2x, -2 times x, right? -2 times 2y, and -2 times 20. So I'm going to have -4y equals -40. Alright, so now this equation is gone. This is my new equivalent equation to that, but now it gives me the option to eliminate this x term in front because I've got +2 and a -2. So I've got opposite signs. I can add these two equations together and it'll help me eliminate the x term. So 2 plus a negative 2x is 0. Y plus a negative 4y is going to be a negative 3y. And 19 plus a negative 40 is going to be a negative 21. So then I'll solve for y by dividing by 3. Y is going to equal a positive 7. Taking that and plugging this in, I'm going to plug it into this bottom equation right there. I'm going to plug this into the bottom equation because the x term is positive, and it kind of makes me feel better, I guess. So we're going to have 2 times x plus our value for y, which is 7. It's going to equal 19. So I'm going to take and move the 7 to the other side. This just means I'm going to subtract 7 from both sides. This side would go away, 19 minus 7 on this side. So we're going to have 2x equals 12. 2x equals 12. Then I'll divide by 2, and x is going to equal a positive 6. So now my solution to this system of equations is going to be 6, 7. And I have solved that one. All right. Let's look at number 11. Let's skip down to number 11. On number 11, you're going to notice that I don't have, actually I tell you what, let's look at number 10 real quick. We won't work it, but just we'll kind of get an idea of what we're talking about here when we multiply coefficients. I've got a 9 here and a 3 here, a 4 here and a 10 there. They're not the same. I can get to a 9 from this one by multiplying it by 3, or a negative 3 if I want to make it the opposite sign. So if I'm working number 10, I'm probably going to take and use the x terms and multiply by a negative 3. And that would give me the negative 9 term here to eliminate it. All right? If I'm doing 4 and 10, that's a little more difficult. 4 doesn't go into 10, so now I've got to find something that they both go into if I want to use the y term, which will lead us into number 11 now. So that's how you do number 10. You multiply by negative 3 to get your 2 equations, and you can do the process like we've done before, the previous problems. Number 11, 3 doesn't go into 4, neither does 4 go into 3, obviously. 5 doesn't go into 3, and 3 doesn't go into 5. So now I've got to find 2 numbers. I've got to multiply the top equation by a number and the bottom equation by a number to get to a factor or to a result that gives me the same coefficient in the x terms or the same coefficient in the y terms. In many cases, whenever you're doing this, it's simply the 2 numbers times each other, because they both will go into 12, won't they? 3 times 4 and 4 times 3. They're both factors. So we could, if we're going to use the x term to deal with here, we can multiply by 4 on the top, and multiply by 3 on the bottom. And that would give me a negative 12 and a negative 12 on the bottom. Do we want negative and negative? That's fine. We can do that because then we'll show the example of subtracting. So let's multiply the top one by the 4, the bottom one by a 3, and that will give us the same coefficient for x. So we're going to have 4 times negative 3 is going to be a negative 12x. 4 times negative 5 is going to be negative 20y. 4 times negative 7 is going to be negative 28. And that's the top equation multiplied by 4. It's equivalent to that same equation. The bottom equation now is going to be a negative 12x, 3 times negative 4, and 3 times negative 3 is going to be negative 9y. And 3 times negative 2 is going to be a negative 6. Alright, now we've got 2 equations with the same coefficient. They happen to have the same sign, and that's okay. So when the signs are the same, we're going to subtract. So this will be a good example of subtracting. Okay? So now let's look at it. We're going to take and subtract every column. Okay, you're subtracting every like term here. Negative 12, subtract a negative means positive. So negative 12, positive 12, makes it go away. That's exactly what we were looking for, and that's what we got. So The negative 20 minus a negative 9 is negative 20 plus 9. And negative 20 plus 9 is a negative 11y. Negative 20 plus 9. Okay? Now the next one, negative 28 minus a negative 6, or negative 28 plus 6. Minus a negative is plus. Okay, we had a little video glitch there, but we were saying that negative 28 minus a negative 6 is the same thing as negative 28 plus 6, so we get a negative 22. And then we can take and divide by the negative 11 to solve for y. When we divide by negative 11, y equals positive 2. And that works out nicely now. We're just going to take this positive 2. We're going to plug it into either one of these equations. They both have a leading term here for x, the leading coefficients and negatives, so it doesn't matter. We're just going to plug it into one of them. We'll pick let's pick the bottom one, I guess you could say. Or we could take one of the original ones. Let's pick the very top equation of the original equation. So we're going to have negative 3x minus, so I'm taking this and plugging this into that equation, negative 3x minus 5 times 2, plugging that right in there, equals a negative 7. So negative 3x minus 10 equals negative 7. Alright, and then we'll add 10 to both sides, or we'll just move this across to the other side, same thing. So negative 3x is going to equal a positive 3. We'll divide by negative 3, divide by negative 3, x is going to equal a negative 1. So the solution to this system of linear equations is going to be a negative 1, comma 2, and that is the answer to number 11. Alright, I think we can do one more example here. You notice we skipped on our examples. I went ahead and skipped a few because there were several examples here, and I feel like we covered enough of these that you understand it, should have a grasp of it. So this goes from 12 to 15. We skipped 13, 14, 15 here. Let's do, I tell you what, let's do number 16, and then we'll work the word problem and close the notes video out. So we're going to have number 16 here is 4x plus 3y equals negative 7. Negative 2x minus 5y equals 7. So if we're going to pick one, I think the easiest one would be which variable here. Which variable would be the easiest one to try to match up coefficients? The x variable would be probably easiest because all we'll have to do is multiply by 2, and we get a negative 4 right here, and that matches the coefficient in the first equation. So if we multiply the bottom one by 2, then we should get negative 4x minus 10y equals 14. Alright? Negative 4x minus 10y equals 14. I'm going to go ahead and write the other equation right below it so we've got them stacked on top of each other. We're going to have 4x plus 3y equals negative 7. Alright, and then now, because they're the same coefficient but different signs, so we have opposite signs, means that we add. So we're going to add the x terms, the y terms, and the integers. That goes away. This will be a negative 7y. This will be a positive 7. So we divide by negative 7, divide by negative 7, y equals a negative 1. We can just take that, and I'm going to plug it in to this equation, which is the first equation, and solve for x. So 4x plus 3 times the y value, negative 1, equals a negative 7. 4x plus 3 times negative 1 equals negative 7. This is a negative 3. So 4x minus 3 equals negative 7. I'm going to take and move that over here. So 4x is going to equal a negative 4. When I divide by 4, x is going to equal a negative 1 as well. So we've got both of them equal to a negative 1. The solution to this system of linear equations is negative 1, negative 1. Alright, and you're going to do much of the same on 17 and 18. You're probably going to have to multiply by 2 different numbers here. If I'm probably going to pick the y term because I can just multiply the top one by 4, the bottom one by 3, and I get negative 12 and positive 12 for my y terms. And I can eliminate those by just adding them together. On 18, I would probably just pick my x ones here, multiply the bottom one by 3, the top one by 2, because that would give me negative 6x and a positive 6x. But let's look at number 19, the word problem. It says the sum, and that is addition. The sum of two numbers is 22. So x plus y equals 22. It says the difference, which is subtraction, x minus y is equal to 6. Well, this is easy because we have the same coefficient, opposite signs for y, same coefficient for x. We could add or subtract these and it'll get rid of one or the other and we're in good shape. Alright, so let's just add these together. So let's add them together. I'm going to end up with 2x. This one becomes a 0 equals 28. I'll divide by 2. That just goes away. Divide by 2 and x is going to equal 14. I'll take that 14 and I'll plug it into, let's plug it into the top equation because that's the one that's positive for y. So then I'm going to have 14 plus y equals 22. I'm going to take this 14 and move it over here. So that means I'm going to subtract 14 from both sides. Y is going to equal 8. So, the two numbers are 14 and 8. If I add those two together, I get 22. If I subtract 8 from 14, I get 6. So the solution to this one right here, the two numbers are 14 and 8. And that concludes the notes for 5.3. Hope you have learned a little bit here. We will work on the practice on our next class period. Y'all have a great day.